Today we're going to learn functions. So let's make this center line and this nice dot graph. And this will be the middle. First things first. How to find a value of a function at a specific point. Let's make a very weird function. So, this being 1, this being 2. What is the value of function x equals to 5? If x equals to 5, the value is 0. So fx5 is 0. 5 is 0. Now what if you have, say, 2? Well, now 2 on the y-axis, we can check 1, 2, 3, 4, 5, 6, 7, 8. Over here, this is being 2, so 9. So the value of 2 is 9 for the function. Using this, we can find the value of anything on the graph. So that is very simple concept. Now let's see what is the domain of this graph. So let's make some dotted lines. How far does the x-axis can go? What is the limit of the x-axis for this function? Looking at the function, this can keep going on to infinity. This goes on. So the set of all x values in this graph is negative infinity to positive infinity. But what about y? There's this little dashed line over here. The values can go from negative infinity, but to what? It has to be to this line. And while we know that this is 9, this is 10, so this is 11. It can never go above 11. When it never hits 11, just imagine this never hits. It just narrowly misses. Then the range, or a set of all possible y values for this graph, is written like this. It never hits 11. There goes less than that. There's no line, but it only goes to 11 if there was no line over here. If we didn't have this dotted line, if I didn't put this dotted line, then it would have been greater than, or less than 11. It would have been less than or equal to 11. So this is the domain and range. To find the domain and range of a function is to look at its graph and see how far can the x values go? Where are the possible x values to y values? Let's make a new graph. So we have this coordinate grid. Now, say we put some dotted lines. I'm gonna have to make you find the domain and range. So let's find the limit of x and y. So what is the domain of this function? Well, look at this line. The domain can never ever hit this line. So it is less than this. The domain goes from negative infinity to that line. Or we can write it as less than Never equal to again, never equal to. And then what is this? 1, 2, 3, 4, 5, 6. This is the domain of this function. And now let's find the range, the set of all possible y values. The y values can always go less than this line over here. And where is that? 1, 2, 3, 4, 5, 6. Oh, it's also 6. Well, that's a coincidence. So it's also less than 6. The domain and range are the same, which I never expected. But yes, this is the domain and this is the range of this function. Now I think you understand the basics. But wait, what if you want to graph a function? Let's graph a linear function. For the sake of time, let's just make a short linear function graph. So let's take the most basics of it. Let's take the linear function 3x plus 2. We only need 2 points. So let's take one point, say 5, and another point, say -2. So 5, 17. Now that is too big, so let's take a smaller example. Let's have 2. That is 8. And -2, -4. So if we can get 2, 1, 2, 3, 5, 6, 7, 8. So we can put a point over there. And then we can graph -2, 4. So this is -1, -2. So -1, -2, -3, -4. And now we just connect these points. This is how you graph a function. This is practically how you graph for linear functions. Quadratic functions, you need like about 6 or 7 points to make a parabola, the graph of a quadratic function. But again, for the sake of time, we're just doing a linear function. Now if we can graph another function. And if those 2 points meet, we can find the solution to simultaneous equation. But that's for a different video. Now, this is the graph. We can find the domain and range. There is no limit for the domain and range. So the domain and range is both -infinity to +infinity. If you know set theory, you can also write it as a universal set of numbers. But not... Yeah, it's the universal set of numbers. You can also use decimals. But if you can use a set R for rational numbers. But yes, these are the domain and range of this graph. The graph fx 3x plus 2. Thank you for watching. See you later. See you tomorrow.